Hello and welcome. I'd like to welcome you to our Canon Automation webinar on functional safety in CAN systems. My name is Thilo Schumann. I'm an electrical engineer. For more than 25 years, I'm with Canon Automation. Over the years, I was involved in many standardization projects from Canon Automation regarding CAN and CAN Open and maybe some other related topics which involved in one or the other way CAN. In the last years, or also for 25 years, I'm responsible or involved in the specification of CAN Open Safety, and I'm also an expert in the safety communication group for international standardization on our national mirroring committee, and I'm also involved lately in different security topics. What does functional safety means? Functional safety needs to be considered in regards with the EU machine regulation. Some other countries have similar things, but mainly here in the EU, we have our machine regulation or machine directive in the past. And basically, functional safety in the context of the EU machine regulation refers to the safety that depends on the correct functioning of a control system. It is a critical aspect of the EU's health and safety requirements, ensuring that machine operates safely and poses no hazards to users or the environment. The regulation 2023-1230, which is the EU machine regulation, outlines these requirements, emphasizing the importance of risk assessment and the reduction of risk associated with machinery. The regulation aims to protect both the public and workers by ensuring that machinery meets a high standard of safety before being placed in the European market. So that basically generalizes or sums up what the EU machine regulation is for. So the question is, what is the key principles behind? And the key principle for functional safety, in particular the context of the EU machinery regulation, encompasses several crucial aspects. The machinery must be designed and constructed with safety as a paramount concern, incorporating necessary safeguards and features to prevent accidents. A thorough risk assessment is essential to identify potential hazards and ensure compliance with health and safety requirements, and the machinery must undergo rigorous testing and certification to verify that it meets established safety standards. These principles form the foundation of ensuring a high level of protection for users and align with the objectives set out by the regulation. So to fulfill all this, and as you can see, that is always regarding the whole machinery. With our CAN-based communication, we are only a small part in the whole machinery, but we have to fit into the whole picture of that. Before I go into the details for that topic, I want to shortly introduce for some of you who don't know Canon Automation. I want to outline our objective, and Canon Automation is the international users and manufacturers group that develops and supports CAN Open and other CAN-based cellular protocols. We were founded in the 1992 and provide CAN-based technical product and marketing information since then. And our main topic is to foster the image of CAN technology and provide a path to future network technologies. We have done it in the past and doing so right now with the further development of CAN, namely CAN-FD and CAN-XL. I will have later some words for that as well from the functional safety point of view. CAN Automation, as a non-profit organization, has members worldwide. We are more than 750 members worldwide in this year. And you see, even as the majority of the members are from Central Europe, we are represented worldwide with areas like North America, with the Far East, and we even have a member in Australia. As I said, Canon Automation was founded in 1992. We are publishing since then our CAN newsletter with the latest information regarding CAN technologies and different areas where CAN is used. We participate in many different international exhibition and fairs, and we are, of course, developing together with our members and building a platform for our members to develop different specifications regarding CAN-based technologies. Also, an important area or platform we provide is our International CAN Conference, where different experts from the area come together and give technical papers and present them on what is happening related to CAN and the further development of CAN. As I said, we also, at our ICC, at our International CAN Conference, CAN-FD was introduced over 10 years ago. And just a few years ago, CAN-XL was also introduced. Our main topic are our CAN specifications, CAN-related specifications, and we provide them to our members as well as non-members, and we provide all our services or organize our services around those specifications, meaning on the technical side, like seminars, on the marketing side, we discuss them in our CAN newsletter and in other areas and conferences and things like that. As I said, our main focus are our technical specifications. So we have many different technical groups covering the different areas, like technical groups for CAN Open, for CAN Open FD, for our application and device profiles, as well as for the further development for CAN-FD, CAN-FD Lite, CAN-XL. And we have a dedicated group for our safety and security, and I will come later to that topic. As I said, we provide different publications, like our CAN newsletter magazine, which you can download as a PDF, and it will be also distributed in paper at the Embedded World Conference in North America in 2 weeks. We provide also our product guides, and we have, for more information, also our website, and if you want to join in, our email services. That basically sums up all the topics, all the things which I have discussed right now. You can be part of our organization as a member, and this gives you individual advantages, like you have access to all specifications in all development stages. You can also actively participate in the development of the specification and as such influence the specifications to your specific requirements and needs. You can also participate in different joint marketing activities and have cost benefits at different other services which we provide, like our CAN conferences or our seminars and the like. Coming back to the main topic on functional safety in regarding to CAN-related communication and functional safety related to communication in general. In the European Union, it started around mid-1990s with the publication, with the first edition of the publication of EN 954, part 1. That is being obsolete right now, and but it was happened years ago. At the end of the last century, basically, the IEC 61508 was developed and published, which lays down the foundation for functional safety in general, for functional safe device development, for functional safe communication, and in general for all the electronics which require functional safety. Almost in parallel for machinery, the ISO 13849 was published, which is laying down the foundation for the general definitions of for functional safety in electrical machines. Around that time, we started also with the development of safety-related communication based for CAN and mainly also based for CAN Open. So we started CAN Open Safety. That was then early on published as our specification CiA 304. In the meantime, many other specifications have developed. I have to mention specifically IEC 61784 Part 3, which lays down the foundation for any functional safety communication network for basically field bus communication. That is the general document. I participated in the development of that, and that was also the foundation for our CAN Open Safety specification to be then later on being released as a European standard, namely EN 5325 Part 5. Just before the publishing of the specification of the general functional safety specification for field bus communication, the machine directive in the EU became the standard and had to be applied. The machine directive from 2006 is now being replaced with the machine regulation 2023. So that was basically published last year. Parts of that regulation became active with July 1st of this year, but the main parts of the new regulation will become active and requirement with the year 2027. And you see, in the meantime, in the timeline, other specifications have been published as well. I want to highlight here also in 2020 the SAE J1939 Part 7.6 and Part 7.7, which covers the J1939 communication related to functional safety. I will also have some words on that. If you look back and if we look forward, we have 3 generations of CAN with the published and in use of CAN CC, or the original CAN from 1986. As I mentioned, we have our second generation of CAN FD, released in 2012. And we have our newest generation of CAN XL, released in 2021. So that basically means we have 3 generations of CAN. And if we look at the data frame format of the 3 generations of CAN, from CAN CC to over CAN FD to CAN XL, we see always the general same principle. We have an arbitration field, which is used for priority and addressing. And we have our data field, which originally in CAN CC can contain something in between 0 to 8 data bytes. With the release of CAN-FD, we are using the same structure, except that the data field can now contain up to 64 bytes, and we can increase the data rate of the data frame. So the data in the data transmission phase of up to 8 megabits per second, so that we can transmit more data faster. And now with the release of CAN-XL, we almost contain the same structure. We have also our arbitration field, which marks only to be used for priority purposes. We have added additional identification for data type identification, so we can identify directly what type of data shall be transmitted in the or is transmitted in the CAN-XL frame. We enable additional higher layer functions, which allows fragmentation and security. Maybe we, on requirement, we add also for safety. And we have the possibility to add virtual networks, and we have a dedicated address information now. And the data field can cover up to 2 kilobytes. I see we have a first question, which reads, what was the first standard that prescribed functional safety layer in communication interface? I don't know what is meant with communication interface. In general, related to CAN, the CiA 304 was the first for functional safety in CAN-based communication, and then was later published as the European standard. So I hope that answers your question. In general, for non-CAN-based communication, I don't know what was the very first. So with those 3 generations of CAN, I will first start with CAN-CC. With CAN-CC, as it is a very simple network, all the functional safety related communication networks cover a simple CAN-based network, a simple CAN-based system that mainly incorporates, I have maybe at least one controller in my system, like at least one PLC, maybe more, and I have several devices connected to the network. Some devices are for general purpose control because I need to maintain my function, my machine function, and some devices are safety related. So I want to connect all the devices to this very same network, and I want to do that in a very simple fashion and in a very easy fashion. For that, we have basically 2 implementations and definitions, namely CAN Open Safety as standardized available today at EN 5325 Part 5. And we have SIE J1939 Safety, which is available in Part 76 and 77. And the main idea behind them is the functional safety and the communication layers is I'm directly on the network. I have no active networks in the network except maybe some repeaters. I have no gateways whatsoever. If I need a gateway to communicate to another network, I need to implement the gateway as a functional safety gateway. So I need to implement all the functional safety into the gateway or router or similar. That means we are basically using what is called a wide channel network because we are using the features of the underlying network. Or in terms of CAN Open Safety, the original idea behind CAN Open Safety is we want to utilize the reliability of CAN because CAN itself has a very high reliability designed in. We want to make it possible to allow simple implementations without the need of additional CRC. If you remember the timeline, we started at the end of the last century, and microcontroller implementations at that time had no CRCs. Normally, only very expensive microcontrollers had additional CRCs in hardware available. And we wanted to have something which doesn't require additional CRC. So in general, we wanted to have and to allow a small footprint, and we, at the end of the last century, we covered only isolated networks. For CAN Open Safety protocol, that was a very simple task because we needed only to transmit 2 CAN messages, where the first message is our regular CAN message, and the second message is the bitwise inverted data of the first CAN message. With that, on the receiver side, I can make a simple cross check. I don't have to calculate any CRC. And if both messages are being received in time and I can do my cross check, then everything is okay and I can run my application. If one of those messages is being corrupted, then something happened and I have to go into a safe state, whatever a safe state means. I said both messages need to be received in time to allow for the cross-checking. That means receiving in time means I have some timing requirements, of course. If I look into here, that means both messages needs to be transmitted periodically in a periodic time we call refresh time. And then the receiver of the messages can check if the messages are received within the safety cycle time. And if the safety cycle time is expired, then something happened and I need to go into the safe state. On the other side, I need to also receive both messages to be able to make the cross-check. So for that, I need also a timing monitoring on the reception of both messages. We call the safety relevant or related validation time. And if that is expired, then I also need to go into the safe state. So from the implementation side, CAN Open Safety is a very, very simple protocol. And that was the general idea behind that. With that, if we look at the table of what of errors can occur in the transmission of a system and what different type of checks I can apply, we have fulfilled and marked all the at least one green point in all the rows, and with that we are compliant and according to the requirements of functional safety. And with a deep analysis of this, we can say the residual error rate of a regular CAN network is 7 in the power of 10 multiplied 10 in the power of -9, and we can apply that residual error probability 2 times. And with that, we fulfill all the requirements for functional safety up to CIL level 3. And with that, a simple implementation can be done. We have published different reference designs for a 16-bit microcontroller that was before ARM Cortex were available on the market. With today's microcontrollers available, which are much more capable than 20 years ago, all these things can be done very easily. If we look to on the other side, in trucks and buses, like in the CiA J939, and the safety requirements, there is specifically an article in our CAN newsletter of June this year. You can use the QR code to download the CAN newsletter. And yeah, if you look to the requirements, of course, the requirements for J9039, we want to use or utilize the reliability of CAN. We want to allow simple implementations, small footprint, and in trucks and buses, we are more or less also on an isolated net. So as we can see, the general safety requirements are the same, like with CAN Open. And so they found the same solution. And the same solution is here, it is called the safety data group. The safety data group is a little bit different, but almost the same. The safety data group contains here, we first transmit a first message, which is called the safety header message, or called SHM. The safety header message contains a sequence number, contains a reference to the data message, and contains a CRC. And then comes the safety data message, which contains the data. And the safety data message is a regular J9039 message, a normal PGN or group message, as we have regular use. So it doesn't need any change in J9039 implementation whatsoever in the transmission of the data. It just needed a safety addition to allow for safety. As I said, the details are laid down in an article, in a very great article in our CAN newsletter. Also here, we have some timing requirements for J9039. And as you can see, we have the same timing requirements. We have periodically transmit. We have a safety cycle time for monitoring that the periodic transmission is maintained. And we also need to verify if both messages are received in time. And for that, we have the safety relevant validation time. So we see J9039 in general uses the same underlying principles with a slight variation that it is using a CRC. Also, if we look at a table of safety measures, we see the same requirements are all fulfilled. So that was for CAN CC or classical CAN. What is about CAN FD? We published CAN FD more than 10 years ago. What is available for CAN FD? And CAN FD normally works in the same realm as CAN CC. And so that means on CAN FD, I could use our CAN Open and with CAN Open on CAN FD networks. And as such, I could use CAN Open Safety. I don't have to go into details here. And CiA J9039 safety has dedicated definitions also for the use of CAN FD. But the general principle is the very same as explained with CAN CC. With CAN XL, now we add CAN XL to the mix. As I said previously, we have now additional information to identify the data to be transmitted. We have additional possibilities to include a special higher layer function, maybe a dedicated higher layer function for safety. And we have dedicated addressing information, which allows basically routing. And the problem here is, as I said, CAN CC and CAN FD is, as it is used today, for isolated networks. With CAN-XL, we allow routing. So we have a new requirement on that level. So that means we have new requirement or new possibilities with CAN-XL. Up to now, we have no dedicated functional safety communication for CAN-XL defined. And we are currently in the process of in the process of defining a functional safety protocol for the use on CAN-XL. As I said, we now have a new machine directive, which comes into place in 2027, finally. This new machine directive has also new requirements, especially if we allow remote networks. So that means we need security for remote monitoring. We need additional security requirements for remote software updates. And all this thing is now open the topic on how to proceed. Do we go further on with the white channel approach, or do we go with a black channel approach? The white channel approach, as we used in CAN-CC and CAN-FD, utilizes the features of the underlying communication, so allows simpler device implementations. On the other side, the black channel approach doesn't care about the underlying communication, but allows end-to-end communication over routers, gateways, communication interfaces. And as it allows communication over those things, those need to be implemented as safety-related devices. So it makes the implementation of those easier because it doesn't need any certification. Just to highlight again the differences in machine directive versus regulation, what are the changes? The main innovation is the coverage of new risks associated with the digital technologies. It means it is constantly now a reassessment of high-risk machines required. And it's a reduction of the paper-based documentation requirements. But the more important part for us is it advances new risks in machineries, especially with human-robot collaboration, or cobots, as they are called sometimes, with machines connected to the internet. It affects software updates, and also it affects autonomous machines and remote monitoring. So those are the main topics which are now in the new machine regulation are being covered. So what does it mean, risk assessment for machinery with autonomous behavior? The problem with such machinery is that those machinery is normally put in place on the market and into service. And it may changes on the market itself, because autonomous behavior means autonomous learning and stuff like that. So that means the risk assessment must be carried out as normally, but it needs to be covered that as the behavior improves over time, the risk assessment still ensures safety. So that needs to be ensured by the manufacturer. So safety becomes a process, an ongoing process, and it needs to be monitored, and risk assessment needs to be done continuously on to ensure the safety of the autonomous machine and vehicle. And as I said, we have new IT security requirements because we are connected to the internet or by other means to other networks for remote monitoring, for software download, for over-the-air updates, all these kind of things. And that needs to be done. So it needs to be considered what those IT security that according security requirements are in place, that the safety of the system can always be maintained, that not through a malicious actor the safety can be disabled or something like that, or the machine can be tampered with. Before I'm going through the questions, I'm going back short for the requirements for future functional safety. So I'm going back to that for. So we see that with the new machine regulation, we have together with those additional connection to other networks, to the internet, we have also additional requirements here. As CanXL allows especially more data to be transmitted, we have to discuss what is possible, what is the future we are going with. And so we have no solution for that. I just can invite you to join CiA and to join our functional safety group to be part in shaping the future for functional safety communication on specifically on CanXL and partly on CanFD. With that, I want to have, I'm looking always for, is there an XKCD for anything? And yes, there is a XKCD for everything, also for covering safety. And for that, I see there were some questions, and I will repeat them, and I will try to answer them. And first question is CanOpen reliable enough to satisfy requirements of SIL 2? No. Generic CanOpen is not reliable enough to cover the requirements of SIL 2. CanOpen Safety needs to be used for that. CanOpen Safety is designed for SIL 3 requirements, but of course SIL 2 applications can also be implemented with that. So pure CanOpen cannot be used, but together, and CanOpen Safety is designed to plug in basically together with existing CanOpen applications, and together it forms or it enables the implementation of SIL 2 applications. The next question is, it is correct that risk assessment is mandatory for machine builders and not for suppliers of safety components. In general, the original machine directive and also the machine regulation is applying to the machine. So that means the risk assessment needs to be done for the machine, always for the complete system, for the complete machine. For that, the risk assessment needs to be done. The problem, of course, for a machine builder is he needs to implement then the machine by buying components, devices, and connecting them together, and needs to fulfill the requirements for safety. And for that, he needs devices, components to fulfill, he can rely on basically to allow the building of the machine. So for a device manufacturer, risk assessment is difficult on one side, because as a device manufacturer, I don't know how my device is used by the machine builder, but I can provide some information on that. Like, for example, even with a digital input module, I don't know, I can do some kind of risk assessment for my digital input module, in terms of I can look into the module what type of errors, of type of failures could happen, and how my device reacts, and go into a safe state. And for a digital input mod or digital input is easier. I mean more maybe for a digital output module. What is the safe state for digital output? Is it needs to be set to a certain voltage? Does it needs to be set to enable the digital output or disable the? What is the safe state? What compromises the safe state of the device? So yes, I need to make a risk assessment and have to define how my device behaves if it is if it detects an error. But I don't know how the machine builder uses my device in a system. Maybe the machine builder needs that the digital output is being enabled for the safe state of the machine. Maybe it needs that the device is being disabled, the digital output is being disabled in the machine. And so, yes, as a device builder, as a component manufacturer, I need to make a risk assessment in terms of my device and look what can happen and how should I react on. But it is but the machine builder has to do it anyway. So the next question I have seen is, since almost all drive solutions relate on classical CAN, are there any activities in regarding to bring classical CAN to stage where CIL3 at a reasonable update rate can be reached, or are the activities of CiA only related to CAN-XL? We have CiA 402 has additions for CAN Open Safety, so that functional safe drives can be implemented. So for CAN Open Safety, it has additions in there. We have updated it for some time right now. And then I have a question. It's a different, I know it's a different topic, but cybersecurity is related somehow. The upcoming CiA has some requirements which can't be addressed by CAN from my point of view. Can you say something about that? We have also security definitions or security considerations, cybersecurity consideration for CAN-based system going on. So for CAN-XL, we define security into the protocol. And in our security group, we are also defining a generic security protocol, which can be used on CAN-FD and on classical CAN, and will be also compatible with CAN Open. The problem with the CiA is, in general, it is very vague. It needs to be interpreted. What is some of the requirements will be. Some things maybe don't require additional security functions because we have it already available in CAN Open. And in general, it is the same thing like with safety. It needs a risk assessment needs to be done from the system manufacturer, from the machine manufacturer, and from that point on, it needs to be looked at what functions I need to implement to fulfill the requirements according to the risk assessment. And so for security, it will be the same requirements in general like for safety. So that are the questions I have seen. I hope I have them answered to your likeness. And with that, I like to thank you in the participation of this webinar. If you have any questions, you can send them to our service account with service@CiA.org. You can subscribe to our mailing services with mail@CanCiA.org. Thank you.